Okay, good morning, everyone. I'm actually not your speaker today. My name is Lawrence Chin. I'm part of the Industry Initiatives team at Palo Alto Networks. And since this session certainly has a little bit of an industry flavor, we want to take a moment, literally I'm going to steal a minute, to tell you about some of the other industry-focused things that are going on at Ignite and that you can look at when you get back home as well. So first of all, one of the things that you may have noticed that on your badges, right next to your name, there's an icon with your affiliated industry. The intent behind that is that you guys can find other folks in your industry and network with them during the coffee breaks, lunchtime, that sort of thing. So certainly please take advantage of that. Additionally, today and tomorrow we have these industry roundtables that are occurring at lunchtime. And for those of you who were able to secure a seat at those tables, please be on time. What will happen is those roundtables start at 11:30, and certainly for any empty seats at 11:40, those seats are going to get filled with folks who are standing by on the wait list. So please get yourself there on time. Additionally, there are a couple events that have been going on in terms of both the cyber range, that's downstairs in the expo hall, and there's also a hands-on workshop for industrial control. So certainly if you guys are interested in those things, you can take a look and see what's going on there. And if you can't get to those sessions, there are other opportunities for cyber range at permanent facilities across the globe, and then also for the industrial control hands-on workshop as well. And of course, on our website, when you get back home, there are some pages there that contain information about different industries, industry-specific materials that you might find interesting, so give that a look. And then, of course, we have the Fuel user group. So there are also a number of special interest groups within Fuel. Actually, I should have advanced this slide. This was obviously not well rehearsed. But anyway, there's a Fuel user group. They have a booth downstairs in the expo hall. And additionally, there are 9 different special interest groups dedicated to different industries. So certainly check that out. Again, continue networking with your peers either through the local Fuel chapters or online through that community as well. And then last but not least, I know we're only about halfway through, a little more than halfway through Ignite in Anaheim. But if you're inspired next year to share your story, certainly let us know if you're interested in presenting at Ignite 2019, which will be in Austin, Texas. And with that, I'm going to turn it over to Shankar and to Vinay, and I'll let them introduce themselves. Gentlemen, the stage is yours.
Thanks a lot, Lawrence. Hi, everyone. Good morning. Thank you for being here. I guess this early, we got prime time here. But what we're going to do today is take you through a very interesting journey, I hope, of the partnership between Palo Alto Networks and Moody's. My name is Vinay Venkatravan. I'm a solutions architect in the technical integrations and developer relations teams at Palo Alto, and my focus has been on cloud integrations. How can we leverage the best of breed tools to bring automation and make security very agile as you move into the cloud. And today I'm very privileged and honored to introduce Shankar, Shekar, who is from Moody's, and we have partnered to build a lot of solutions. And Shankar, could you please take it away from here?
Sure. So my name is Shankar Shekar. I head the Moody's cybersecurity engineering group. One of our basic focuses is also enabling the business to move to the cloud, enabling my developers to be agile, use cutting-edge technology, and with security in mind and focus. So this is something about who we are and what we do for people who don't know who we are. What we do is we are divided into 2 major entities. One is Moody's Investor Services and Analytics. The Investor Services is the regulated part of our business. Basically, what do you see in news where Moody's ahead and rates a country, organization, or any form of small and medium banks. The analytics is a more advisory business. They provide advisory counseling on ratings, and they provide economic analysis. We have a lot of financial instruments that provide these analysis. So think we can move on to
Yeah.
the.
Oops, where did that go? Okay, so before we get into the meat of this presentation, I just wanted to provide an overview of this the presentation, and as well as some of the cloud automation drivers, right? As it's probably not a surprise to most of us who are indexing the cloud and looking at it to run our critical workloads. What are the benefits of the cloud, right? It's the agility, the ability to combine DevOps, DevSecOps, and bring all of those together so you have secure cloud adoption for your critical applications. And I would imagine a lot of you are also looking at multi-cloud footprints to deploy all your applications to leverage all the different capabilities, right? So as we recognize that, so we also recognize the need, just like from a networking perspective, we have the OSI stack. What's actually organically developed here is a cloud security automation stack. So we'll talk about that and the benefits that you can derive from such a characterization. So we will also talk about what capabilities that Palo Alto has inherently built out to help our customers leverage the cloud in a very secure manner. And then we will also showcase, and what we'll actually do is take you through this journey as we talked about, as to how Moody's has built out their infrastructure, leveraging all the capabilities of the cloud combined with the native capabilities of the Palo Alto next generation firewall platform, and wove it all together using automation, self-service, and really harnessing that agility. So, and then as part of this discussion, what came about is, cloud is all about agility, and agility comes with loosely coupled interfaces. It needs to be composable so that you can build, every environment is different. So how can you use all these building blocks and make it composable to suit your specific needs? So we'll talk about that. And then some other interesting aspects that have also come about is, once again, it's the agility, self-service, and it's also this concept about distributable security. So how you can build distributable security for your app teams. And so we're going to talk about that. I don't want to get ahead of myself, but there's a very interesting story around distributable security. And then the overarching message is all about how we brought all of this together and how Moody's was able to adopt cloud and automation and recognize our tremendous benefits.
Yeah, I think to just add to that, being able to adopt something at a financial organization and being able to move at the pace at which the developers are moving or the industry is moving was paramount to Moody's. So I think that's where the whole cloud adoption and its benefits were really highlighted.
So just want to once again reiterate and level set, right? So we're going to talk about the need for automation at Moody's, right? But generically speaking, what you see is, you have your app teams, and ultimately at the end of the day, you want your line of business applications deployed in the cloud, right? That's what your goal is. So you want your app dev teams to go through their life cycle, app development, test, move into production, and you want to do this in a very rapid manner. Obviously what we've heard is, and maybe a lot of our experience is that this doesn't move as fast as we would like, right? And there are consequences to your business needs and so on. So how can we address those challenges, right? So once again, now, once you get there, you also want to improve your security. There's potential where, all the cloud providers have native security capabilities, and how you want to actually augment that security with capabilities from the VM series platform, for example. So you want an improved security posture, you want that increased agility, and above all, this is not easy, but can we achieve it with reduced effort, right? And to achieve your business goals. So once again, this is all about DevOps, right? You want to have clearly defined processes, and you want that agility, but you also want security injected into that process. So now we're going to show you how you can actually convert DevOps into DevSecOps and move security at the speed of your application teams. So Shankar, can you talk about how this need for automation and agility maps to a lot of your use cases and requirements?
Sure. We had a couple of use cases. Moody's Analytics is a business that constantly acquires organizations. We are constantly acquiring organizations. We generally don't tend to change the posture of the organization, so that we don't want to disturb the daily business as usual processes of a profitable organization unless and until it's needed. But we do want the security umbrella to cover this and to make sure that we are enforcing the Moody's global security policies on it. We are enforcing logging standards on it and things along those lines. This is the need that came in because when we wanted to consistently repeat what we were doing and consistently deploy and be less error prone to what we are doing, we started building this whole concept of rather than building things in cloud formation, rather than leveraging ARM templates and being, where we'll have to map the capabilities between different clouds, what we went back and went to the drawing table and I took it to Vinay was, why don't we get everything in a simple format? And that's when the light bulb went off to use Terraform to be able to deploy to multi-cloud environments, because Moody's was leveraging multi-cloud environments. And then the other important benefit I saw was, rather than having training to multiple teams on CFT and ARM, I rather have one single training platform of Terraform where users could just learn Terraform, or my developers could learn Terraform who are already using it and could leverage the security modules written in Terraform to just go deploy and use it as a self-service module. I think that was the key benefits of why Moody's wanted to use Terraform.
Yeah. And as I alluded to earlier, what has come about is this concept of a cloud security automation stack. So let's look at what that looks like, right? So the first layer is the building block layer, is your infrastructure layer. You need to deploy your applications with the right, the plumbing required, the right segmentations, and so on. So this resulted in these Terraform cloud templates. So Shankar, this has resulted in infrastructure as code.
Yeah.
So how has this impacted you guys?
Yeah, when we thought about this, we thought the basic building blocks is not just thinking to build a firewall, or not just thinking to build one single aspect, but to build the entire infrastructure, the underlying nuts and bolts that move this infrastructure in templates. So what we leveraged here is we work together to leverage building a VPC, building security groups, building NACLs, building ability to inject DNS servers in it, ability to put a block list, and all these features that are a basic infrastructure to be built on the cloud through an infrastructure template. And then we moved on to the security layer.
That's right. So the next layer in this is, once you've built out your infrastructure, you obviously want to secure it with the right posture. So to this end, it's this concept of security as code. As you can see, everything is all about immutable infrastructure, defining it as code. You have a repo, everything is auditable, and in that same theme, the next layer was security. And so Shankar, how has this helped you guys in your agility as well?
So yeah, when we talk about security as code, so when we got to building the basic blocks of security and infrastructure, we immediately thought, would it not be better if the same template also had an ability to build a firewall? Not being able to go to a marketplace or being able to deploy a firewall and license it, instead of going through such a manual process. We thought, why not include it in the template, and having us just build a firewall, the security groups around the firewall, the infra the firewall needs, and everything templatized. Being able to, I would even stress upon being able to attach interfaces, public IPs, IPing all these interfaces, allowing some level of traffic flow. I think we got a significant amount of things templatized in the security as code module.
And I just also want to take this opportunity to highlight a brand new feature that we've added, which is Palo Alto is one of the first security vendors to implement a Terraform provider. And what that has resulted in is now all your security policies, your NAT policies, and the configuration for your VM series firewalls can actually be defined as code and pushed out to devices in heterogeneous environments and at scale, right? So the next layer of this is, now that you've defined your infrastructure layer, you have a good process, it's repeatable, then you've also extended that capability to security layer, your job's not done. There's a constantly evolving threat landscape out there. There are newly, as Lee's general session presentation talked about, it's an ever-growing threat landscape. New threats are being developed on a constant basis. So now you need a way to actually index that threat and make sure that your environments are protected against that. So that's what we call the operations layer. So now with a lot of the capabilities that we provide, we have this definition called operations as code. And then I'm going to ask Shankar to talk about what that means and how you were able to integrate that and provide the protection for your applications.
Sure. So when we thought about operations as code, so we built the infrastructure, then we thought the next ideal logical step is to start operating it in a secure fashion, being able to block adversaries and security adversaries and things like that. So immediately we thought about leveraging a native service like Guard Duty, which is constantly monitoring VPCs, constantly monitoring the threat landscape around our environment. So not only just Guard Duty, but other threat intel feeds which we were getting, but all we wanted was this to be automated, not just somebody going in manually setting up these threat intel feeds to come into the firewall and stuff like that. So what we did was I worked with Vinay in this whole Terraform DAG integration, which was exciting because it was not only exciting to build the firewall, build the infrastructure, but now it was getting more exciting because we were now able to block some things which were meant to be blocked, which would have been a manual process, which should have, in Moody's, would have taken at least up to a day or 2 days to be able to go through the change tickets, change process, as we are a complete financial organization and we have a very standard process to do things. This really changed the landscape where we felt like we are ingesting some artificial intelligence or machine learning capabilities into our whole firewall and our environment.
And last but not least, which is the icing on the cake, if you will, is you need all of this to be repeatable, consistent, and agile and secure as you actually start expanding your cloud footprint into different clouds like AWS, Azure, the Google Cloud Platform. And this really, really helps you to put the building blocks together and really be truly agile. And so, this is the point of this is to show you that this is highly extensible, repeatable, and it gives you the agility that you really need to win in the cloud. Go ahead.
I just wanted to add one thing to the last slide. Repeatability was key to us because it was not building one firewall or two. It was now at the scale of building 20, 40, per VPC or per building transit hubs. So it just became an important point to become repeatable and consistent. And I think some of the most security incidents have happened because of misconfigurations. To avoid that, I think repeatable infrastructure was key.
And that's a great segue into this first use case, right? We wanted to enable Moody's and generically speaking, all of our customers to have repeatable, reproducible, and consistent infrastructure. And so to that end, Shankar, can you walk us through this entire journey? I mean, it's better if you talk to it into what it actually took to build out different environments and what was that like?
Sure. When we started our journey in the cloud, we first took a lot of things into consideration. I'm going to talk from a more security angle here. We took building VPCs, building firewalls as key, and then we said, let's go build it. What we saw was, yes, we could build it faster than data center, but no, we couldn't build it at the pace of what the applications teams wanted me to build it at. So what we looked at was, we had like a 3 to 4 week SLA to build a firewall, right? Because we had to build the underlying pipes, the plumbing, secure plumbing, and things like that. Then what happened was these manual processes not only just delayed, with adding to the ticketing processes, we just took a very long time to build all these things out. And each of these blueprints translated to implementation, translated to operations, the pipeline started being 6 to 8 weeks. So we said 8 weeks was not tolerable limit to build up a new region because our developers were promising customers to be able to, customers that they will be delivering certain regions at certain dates, and we were obviously slowing them down. Then we went back to the drawing board and said, we're not going to slow them down. We have to find something where we won't slow them down. And that's when we thought about the whole need of automation. But automation was key with, again, repeatable and consistent ones. So then we went back, after we went back to the drawing board, we created some templates. Then what started happening was we started creating golden configurations, which means the architecture templates with developers and security worked together and created. And these we call them as golden configs. And what happened with this was the developers could just leverage this code build their environment and not having to interface with us at all because we already blessed this type of environment or this config or this blueprint. So in that way, we started becoming faster. Our 6 weeks turned into days, if not minutes, I should say. And we also became extremely reproducible because we started creating a repository of templates, each for different use cases and functions and deployment models. And then it became just reproducible. And now it's only our process of involvement is to create a new template for which we have a certain SLA, which is a pretty compressed one.
Yeah. And just to add one more point to that is, now, anybody who has built out these environments knows it takes a lot of effort, right, to say the least. So now we've built best practices templates that map these kinds of architectures that are readily available for you guys to actually leverage and get started. And the whole idea is these are highly, the composable aspect we'll come to, but you can adapt it to suit your environment needs. But we have hopefully removed a lot of that complexity and barriers for you to adopt these and really get started. So the next use case is a very, very interesting one where Moody's has built out a security hub with application load balancers integrated with VM series and really shown how mapping the cloud native capabilities with the VM series capabilities and really building out a security architecture that really works, scales. And so Shankar is going to talk to you about this very interesting story.
Sure. So, when we started off building our infrastructure, we first started using third-party load balancers. What it quickly added up to us is because our journey had to be fast, we just used them because they worked and we didn't have to test. They were not something we had to try. So we went with some third-party load balancers. And what it quickly added up to us was when we started expanding, the cost was getting very high. So we started feeling the cost, and then we went back and thought, are we using the entire functionality of this third-party load balancer? The answer was really no, because all we did was we just load balanced it to a server, which was a standard load balancer functionality. So we said, why not use it with an application load balancer? Yes, the minute we started that, I think what happened was it started a journey where we had to explore new fields and think about new ideas because natively these were not meant to be working together, right? So we had to work behind the scenes, go through some nuts and bolts changes to make it work together. That's when the application load balancer in front of the VM series was born for us, where what we thought about was one of the key advantages was we are a company who do SSL decryption at the perimeter because we want to see the packet. With the NetScaler, we were not able to get that, and offloading that to the VM series firewall would just stress the firewall for, a VM series firewall comes with like 4 cores. We don't want to take up 2 to 3 cores trying to just do SSL decryption because we want to use it for policies, we want to use it for threat detection, detonation, wildfire, and a whole bunch of other functions. So what we did was we moved the SSL decryption layer to the application load balancer. We offloaded SSL at the application load balancer. What this gave us was a completely decrypted packet that the Palo Alto could inspect with all the threat detection, anti-spyware, anti-malware, and wildfire capabilities. And what this gave us was extreme visibility into the packet while not stressing the VM series firewall and offloading this back into the application load balancer. Not only that, I think it also gave us a lot of bandwidth, scalability, because third-party load balancers don't talk across multiple availability zones. They only talk to one availability zones. You can see one of the application load balancers talks to both the VM series firewall. So we built an inbuilt capability of a cloud-native HA. So we went back and we said, now we are able to deliver HA without deploying 2 firewalls right next to each other. So we were able to deploy it in 2 different availability zones, pass traffic simultaneously, use it as an active-active pair rather than an active-passive, and still be able to get a lot of benefits out of it. I think that was one of the key things what Moody's got out of this.
No, that's great. And as the bullet point said, it's, all these are fully automated. So now they were able to reproduce these kinds of blueprint best practice architectures once defined into different regions in literally a matter of minutes, right? And
Right.
so that's the first step, right? So they've defined their security perimeter hub, if you will, right? So the next part is great, that's interesting, but that's not really useful if you can't integrate it for your actual application. So the next step was to actually automate the build out of the line of business environments, right? So to that end, so now you have your security VPC, so we needed to automate the line of business VPCs, and so we had readily available templates that helped Moody's adopt
Yes.
and address various use cases. Right?
Sure. Once we did this, the ideal flow was we were using IPsec tunnels to go to the back end, and we were talking to a network load balancer, if I may, because network load balancers have static IPs. So we could have a rule that goes from the firewall, hits the network load balancer, and hits the destination server. But then that provided us one great capability, is to be able to leverage network load balancers and have static IPs and being able to map a particular service to particular IP rather than just a URL and with the IPs constantly changing. We leveraged the Palo Alto templates, which they had, and I think we worked on modifying it quite a lot for this use case to be able to leverage the network load balancers to talk to the backend and to do it very smoothly.
And this kind of an architecture also highlights another architecture that even the cloud providers are also proposing, which is, it's also at a high level, it's called the transit VPC architecture now. As you can see, you have your security and your perimeter hub, and then all your line of business applications reside in their own VPCs. And then now, and I just wanted to highlight that. But now the next problem that we needed to talk about was, so once again, all of this is readily automatable, readily easily adoptable. With a few clicks, and we're going to talk about that as well, you can adopt this kind of an architecture, and you can define it with a default fine-grained security posture. So what's the next step, right? So you want to actually integrate these line of business applications with your security hub. Otherwise, they're obviously not useful, right? So let's talk about what that really meant. So over here, what we have shown is now we were able to integrate the security VPC with the line of business VPCs by leveraging a concept called VPC endpoints and private links provided by AWS in this case. And we automated that as well. So Shankar, can you talk about how that really rolled into the full rollout of these kinds of environments?
Sure. So like in the previous slide, we talked about automating the perimeter, automating the lines of businesses. When we did these two, what we figured was the next ideal step is to have a connection between them that's scalable, right? Because when the backend gets a lot of traffic, if you are piping traffic through an IPsec connection, there is a limitation on AWS where the ideal VGWs are just a gig of connection. So we said a gig might not be enough if I'm hosting thousands of servers at the back end. So we needed a highly scalable architecture. That's when I think we had a conversation back in November. We met at AWS last November when AWS announced private links. And then that kept us both thinking on how we could leverage this with the VM series firewall. And we went back to the drawing board and we said, okay, we're probably going to send these traffic from the VM series to the private link and to the private link to the network load balancer in the line of business. What this gave us was speed. We didn't have to manage this connection. It guaranteed uptime because AWS is managing it, and one of the great things was it gave cross-zone load balancing because the perimeter could live in an availability zone like 1A or 1B, and the line of businesses could live in 1D or 1E. And it still didn't matter because AWS managed this link and we didn't have to manage it. All the firewall had to do was the real firewall functions of threat detection and less of routing and more of threat detection and threat prevention. Gave a more bandwidth to the firewall.
Yeah. And I also wanted, this is a great picture to actually stitch all of this together. So now we've automated all aspects of the solution. I think that's really, really key to reiterate. The security hub, the line of business VPCs, and deploying your NAT policies and your security policies on the VM series firewall, which is the pipe that actually sees and inspects all the traffic. So all aspects of this architecture have been automated and easily adoptable by everyone. And so and the benefit is you have application and security, and then you meet your business objectives, right?
Right. It worked out great for us because we were saving costs, we were highly scalable, We were deploying in multiple regions because of automated templates. We were highly consistent. And our time to market to deploy something, I think I should be proud to say, the security team was no more the blocker, right? It was the application teams not being able to develop at our pace, but we were able to bring regions up and be ready for web applications.
That's a first. Yeah, that's a great one.
You have a question, ma'am?
When you say automate in the line, what layer are you automating at? Is it using AWS automation or Palo Alto APIs or something else?
So that's a good question. So the automation is we are using AWS primitives, right? So it is it's a concept called VPC endpoints that allows you to actually have like an endpoint subscribing service in your, let's say in the security VPC, actually connect over a secure channel to an NLB, which is actually the other end of that VPC endpoint. So all that aspect of making the line of business the subscriber and having the Palo Alto be the subscribee and programming the NAT rules, all aspects of that is now available as Terraform templates. So now you can actually parameterize it, use it, and it's highly parameterizable. So that's the key here. So let's say your organization could actually leverage these and actually adopt a similar kind of an architecture.
To just add, we did take it to the abstraction level of using Terraform and not just CFT. So we could leverage this architecture with Terraform. Not only that, it gave us a very highly composable architecture. That goes back to Vinay's point where he said it can be parameterized. That's because you could create multiple network load balancers with multiple private links with a single click. So I think that defined the composability.
So actually, it looks like we could do more. So the next part of this is actually, and this is literally tying this back. I hope you can see that we built out the infrastructure layer. We built out the security layer now. So the next part is your operations layer, right? So let's look at what that looked like. So there was another Moody's use case, right? I mean, and it's also applicable generically, which is to integrate with all these newly discovered threat campaigns and threat sources, right? So what we then did over here is, one such example of such an implementation is implementing AWS has a service called Amazon Guard Duty, where they perform analytics across all their, 100,000 accounts, if you will, to see malicious activities, campaigns, and they surface these IOCs, if you will, right? So now we were actually able to integrate with those IOCs very simply. And once again, everything is automated. That's the key here. And you could actually leverage these and apply it to your environment. So we actually receive these threat intels that is sent into CloudWatch. These are native cloud integration. So actually the other aspect, the real nice aspect of this is natively you can see how we as Palo Alto Networks integrate and play very, very well with various cloud services, right? So once we get that threat intel, it triggers a Lambda function that actually creates a dynamic address group, creates a policy on the VM series firewall, and says, hey, let's say, hey, all these malicious IPs are applied to this particular DAG. This DAG is applied to a security policy which says deny. So now you get ongoing threat protection and prevention on the VM series firewall, but indexed through sourcing this threat IOCs from different environments, right? Sorry.
I just wanted to add a couple of things to that. That Lambda function is extremely generic. So it's not just for guard duty. It could be leveraged for so many different capabilities. We had threat intel from so many financial organizations. We had threat intel from sources like FBI and things like that. So we could integrate everything into the Lambda function and be able to push dynamic objects and drop policies on the fly without having to actually modify policies, modify these groups and things like that.
That's right. Yeah. Yeah, absolutely. Yes. So that's the, thank you.
Thank you. I just wanted to add to that. Moody's is an extensive user of MindMeld. MindMeld is an open source Palo Alto threat prevention platform, threat intel platform. Basically, it's able to mine multiple sources. I think the coolest thing about it is, obviously, it's free. I think that's the best, coolest thing that can happen. But the next best thing that can happen is you could write custom miners, You could actually customize it. Underlyingly, miners are Python scripts. So you could probably write a Python script to go fetch an IP or a list. This also helped us create custom block lists across Moody's. So we could create, we could take high confidence IOC indicators, filter it by the last 24 hours and create a block list so that we keep aging out old stuff and keeping the new stuff on the firewalls. So I think those were like use cases that use these Lambda functions to trigger those.
Yeah, and so to that point, this was one particular integration which showed you how this could leverage a particular source, and I'm going to show you how generic this is. But to that point, MindMeld could easily have been replaced here to enforce similar kind, because there's a lot of threat intel that we can surface through MindMeld and make it actionable as well. So the next slide, actually, and we talked about it already, is this is turning out to be a very, very generic use case as well, right? So these Lambda functions now, what we were able to do is, from an AWS architecture perspective, if you're sitting behind the ALB as per these architectural patterns are panning out, you actually don't see the source IPs, right? So when you do the NAT, you actually see the internal IP of the ALB. So you're missing out on a lot of valuable information. So how are you going to enforce threat from different malicious sources and threat campaigns, right? So we were able to now actually integrate a feature on the VM series firewall through which we can extract the actual source IP from the X forwarding header, and then we can register a user ID mapping on it and enforce security policies. So now, what we have done is we have adapted this Lambda function. It's highly generic, and I just also want to surface the fact that it's a highly generic and it's highly adaptable framework, if you will, to now address different types of use cases. In this particular case, I like to call it the ALB blind spot. So now you actually have the source, the source of the traffic, and then you can enforce policies using the source of the traffic. Guess what? Moody's didn't let us off the hook. We had to do more, I guess, and so he pushed us to do more. So the next use case.
To just add to the previous use case,
Yeah.
I just have one point to say. I think where we saw the maximum use of it is, let's say we have a denial of service attack and we are only getting the 10 IPs on the firewall. This was actually extremely favorable because now we could put policies on an XFF IP and be able to block it specifically. Not just, we didn't have to shut off the whole ALB interface, but we could block a specific IP on the firewall and the specific threat actor.
And also, just to reiterate, it's full defense, right? Now you have full information, full context, and you're able to enforce policies to protect your assets in a comprehensive manner. So what is this more that we had to do, right? So let's talk about it. So this is a use case that I am very close to. It's about being able to distribute and delegate security, especially with containers, right? I mean, containers, if you've been to any of the big cloud conferences, containers are all the rage, but they obviously solve they obviously leverage and bring up some tremendous use cases. So one of the use cases, to me, it's about how do people, our customers and partners, enable and use our platform in a very easy manner. I thought that it has to be highly distributable and easily adaptable to your needs, right? So that's where this was one. So we're going to maybe tag team here a little bit and talk about this particular use case. But so you've deployed your security VPC, and then you deploy your line of business application, right? So the second aspect of this is now you've set up your private link, as we talked about it. This is that blueprint architecture that we have defined. And then the real cool thing aspect now that maybe Shankar you can talk about is how you were able to leverage this concept of composable and distributable security using containers to bring forth that agility in your app teams.
Yeah, after pushing, I mean, Vinay was already working on it, to be honest. So he was already at the cutting edge or bleeding edge, if I may say. When I talked to him and we were going through a conversation, it came up that we want to now distribute these templates, not just keep it to ourselves. But how do we distribute this? Because we are expecting whomever we distribute have Terraform installed, run Terraform on the server. And these are expectations we are going with, or assumptions we are going with when we build these templates. But then what Vinay was working on was containers, and I jumped off my seat and said, I want that. Because what that made happen was we could now take all these templates and containerize it and provide it to my line of business to go spin up their own stuff. not just wait on us. Because we could have them build the whole network load balancer, set up that private link, and connect it up to our firewalls without having us in the mix at all. The reason I'm more stressing on not having security in the mix is because we could work on the next generation of defenses. We could spend our time working on the next threat actors rather than repeating what we have done earlier. So I think containers was the next logical step of, I should say, the next most logical step for us, because we now had built the templates, we now had built architectures, we just had to distribute it in a very standardized fashion.
And this goes back to security being faster than the app guys once again.
Yeah.
Right? Because you have that, unfortunately, our industry as a whole, we are still at that point where we have to have a conversation between the app teams and the security teams. But once that's happened, the security teams can define their blueprint, approved security policies, wrap it in a container, and then send it off to the app team. So once they're ready, they can actually seamlessly go ahead and deploy. So security is no longer the blocker. You really have true agility. App teams can go live once they have gone through their life cycle of dev, test, and they can go into production, right? So once again,
question there.
Sorry, yes.
So how do you know they wrote reasonable good rules?
So actually, very, very, very good question. So at this point, the security teams still control those rules. And there are a lot of other use cases that we can talk about where you can have guardrails and you can have your app team specify their own rules, but you have these pre and post rules that are the guardrails that you can protect and make sure that you're still within the policy that you define.
Doing some automated rule checking of what they create.
So,
yeah, we do have back-end rule checking. We can check for violations. We have things that will scrape the firewall for policy violations and things along those lines. Let's say you're allowing an untrust to trust any or things along those lines. We are obviously checking for that. But at the same time, what we are doing currently is we are publishing out like a golden config with all these templates. And what the lines of business do is they take the golden config and adapt it and re-IP that config to adapt to their use case at this point. Go ahead.
I think I have a similar question, but can I infer that these are not actually being managed by Panorama, and you're not getting visibility from Panorama, they are standalone in that configuration?
Yes, at this point, they are standalone Docker containers that manage these policies.
But those policies could very easily reside in Panorama.
Which is what we are working on right now.
Which is the next step of this evolution, but yes. Yes?
As a follow-up to both of those, what are the limitations around the Terraform provider currently, and building on that, if you're looking at doing something like this with Ansible, if there's not enough core models to do some of the advanced features?
Yeah.
Is the same thing there with Terraform?
Yeah, that's a great question. Just to repeat that question. So what are the current capabilities of the Terraform provider, the features that it covers, and then and try to map that with the capabilities of Ansible and how we can keep up with feature requests, if you will? Right. So fundamentally, thank you for bringing that up, though. Fundamentally, I need to highlight the fact that all of the Ansible playbooks, the Terraform provider, fundamentally work on using our APIs, right? So our APIs obviously address the entire universe of our capabilities. But Ansible and Terraform have been identified as these tools to help with automation and all this agility that we have talked about. So what we have done is, we've been working on it for a couple of years now, especially Ansible. Terraform is quite new from this perspective. But we are doing our best to really hear from the community, hear from our customers. So if you have any specific use cases, we'd love to hear about it firstly. And then we're obviously going to do our best to actually make sure that we can bring that to a GA capability in short order. So that's the kind of cadence. So all of these capabilities are available on our public Git repos. So if there is a feature that you want, please do comment on it. The more that we hear from you, it helps us to prioritize and also get it out faster. So we will be doing as much as we can to make sure that we can keep the Terraform and Ansible capabilities as close to feature parity from our API as possible. But our API is huge, right? I mean, we have a whole bunch of features there, so it's going to be hard to cover the entire universe, but we are going to do our best to make sure that, first of all, we wanted to highlight the most used use cases for example, which is what we're leveraging here. But it's going to be we're going to keep innovating on that and adding more features as we go through. So, I think we have a few more minutes, and I want to wrap it up with this summary slide, and then open up to maybe a few more questions if you have it. So, what I'd like to think about this as a security automation stack, and for me, it's all about how the themes that keep coming back to me are building blocks, how we can do, what can we do with all these different building blocks, like so so that logically broke down into like building like a Roman. I don't know, structure, if you will. So the foundation, if you will, is the Palo Alto VM series firewall, right? So I think we talked about it and showed that all of this is also dependent on the inherent capabilities that the VM series firewall and the platform exposes, DAGs, the ability to create all these security policies, the API capability, and how we can map that to Ansible and Terraform, right? The next step is to build out these pillars, right? So we have these infrastructure templates that are readily available that you can use using best practices, blueprints that are available. So we also have cloud native capabilities. What that is integrating with different types of services like GuardDuty or other services across heterogeneous clouds that we'll bring forward. And the ability to build these endpoints, if you will, but generically speaking, these cloud native tunnels. And then we have our Terraform security provider that's really allowing you to have security as code, if you will. And then how all of that maps into these concepts of DevSecOps. And we also showed that security is getting ahead of the application teams in
I'm
this
feeling
case.
better,
And
actually.
that's a great benefit. It's highly extensible. The concept here is loosely coupled interfaces, so you can see how you can actually mix and match these things to build out your specific use cases. So the beams it's this concept of composable security. We have all these, it seemed like, and Shankar, actually, I have to give you full credit for bringing up this concept of composability, right? Because we were, oftentimes this monolithic implementation might not suit your needs, and it requires a lot of expertise to adapt it. So and Shankar brought this concept about composability. So all of these things, I hope it really shows that it can be composed and used to build your particular structure, if you will. And finally, the cupola is cloud success with security, right? And in the interest of time, I just want to highlight some key takeaways. This is all based on a lot of proven adoption at Moody's. The framework has been developed with real-world use cases and workflows. This is a lot of collaboration based on inputs from our customers and cloud providers. Readily available templates for everyone to adapt and use. It's very easy to adopt, especially with containers. So if you have this question, please ask us. We wanted to remove any kind of difficulty in helping you adopt these kinds of capabilities. It's highly composable, and it also helps you to define these integration points, keep a loosely coupled architecture, but also achieving all your goals in that regard. So I'm now going to turn it over to Shankar for any last closing thoughts.
Yeah, I think overall what I feel is I think composability was key for Moody's. Composability is key for any organization because each organization is very different and the requirements are different. So we had these templates in Git, but it had a lot of work to do. We had to go back and put engineers to work to make it consumable by Moody's. But then when the composability was born, we now could either create a load balancer or use the script to create a VPC. Most of these scripts that are on Git always create a VPC. And most of our requirements in Moody's is we never create a VPC. We already have it created. We just want to deploy within it. So that's when the pain point was born, and that's when I started talking about composability. And I think Vinay has worked far lesser with Palo Altos and more with Moody's now, because he's worked all his last 3 months in getting every single thing on that board work, actually. I think a lot of kudos to Vinay.
No, thank you. But the point here is these were highly reusable, right? And I would imagine, and I would love to hear feedback from all of you, we really hope that all these concepts resonate and show that you can actually use all these different building blocks for your specific purposes. There's nothing, it came in from a lot of great discussions and interactions, but these are representative architectures that really, really help you adopt cloud in a secure manner using Palo Alto capabilities, and it gives you the agility that you really need in the cloud. So with that, we're going to open up to any other questions. Yes?
Your application, are you doing mostly lift and shift, or are you doing refactor?
In our use case, we are doing a lot of refactor. We are not doing a lift and shift, but I should say these templates will work even if you're doing a lift and shift. I mean, it will adapt to every use case, but in the case of Moody's, we refactor it because we want to also use containers and stuff like that. So we do refactor. Yeah, we are using a couple of PaaS services, but we are using more of databases that live within the VPCs rather than PaaS. We do have use cases for RDS. Like I said, Moody's acquires so many companies, and each company comes with a different module. So I have, Moody's has a recent acquisition who's a big partner of Azure. We've been working on AWS all this while. Now we have to start working on Azure. And then we have all these companies that we acquire, small, medium companies that work on different clouds. So our security has to be extremely, an agile team to be able to adapt to anything that's thrown at us. Yeah, we do.
Yes, sir.
Do you have cross-business unit VPC communication?
Sorry?
Business units.
Yeah.
VPCs communicate.
Yes, we do have cross-business VPCs communicating. Most of the use cases are the same line of business has multiple VPCs and they're communicating. That's our ideal use case. But we do have some of the cross-VPC communication.
And do you still achieve layer 7 security with private links out there?
Yes, because private links provide connectivity, and then this connectivity flows back into the firewall, so we're able to achieve it.
So the inspection point continues to be your firewall, and you can route all that traffic.
You're inspecting and training.
Yeah.
Yes.
And moreover, actually, private links also provide you an additional capability of being able to put a security around that private link you create, security group around the private link you create. So you can define firewall as one endpoint of the private link and the other endpoint being the application, and be extremely granular there. So you can control at ALB, the firewall, at the private link, and then at the security group of the instance itself. So it gives you a lot of opportunity to control at 4 different places. Any other questions?
Are you guys fast enough now, or do you still like a containerized service just to
I think we are. Yeah, I think we are fast enough to build standard architectures. I think we could, I mean, if I say minutes, it would not be a fair statement, but we are still like few hours. I'd say if you want a perimeter VPC built at Moody's, we could, using this template, we could be, by end of business day, we could have it ready with all the firewall rules.
So do you have like a big exception in your change control process for all this?
So yeah, we do have exceptions in change control process when we use automation. We are actually trying to leverage to see, if this can now create a ServiceNow or one of these platform tickets where we can create a standard change to allow automation, right? Automation executed from a particular server goes back to auditability of who does the automation, where is it from, and being able to define all these in the document. Sure.
Are you doing 2-week sprints now, or are you still doing 4 weeks?
We are doing 2 weeks. Yeah.
Yes, sir.
I understand the PA has rich capabilities. Can you talk, Shankar, a little bit about where you're using cloud-native firewalls and what functions are being performed there and what functions are being PA?
When you say cloud native, I'm assuming it's only, if it's AWS, it's more of NACLs and security groups. I think even when you're using more of NACLs and security groups, you'll have to be extremely granular. These have limitations. Like I would say a VPC has like 200 NACL rules, and you can put 20 per rule. So the max you can go is 4,000 block list. You can't go beyond that. At the same time, security groups also have, I think you can create 50 of them and 50 rules in each. So that also gives you a permutation and combination number. So we wanted to grow beyond that, right? Because now if we are consuming a feed from one of the government providers, then the feeds are all like 3,000 to 4,000 IPs. So this is just not very scalable in that factor. And the next thing I want to highlight is most of the native features don't give you layer 7 detonation capabilities, which Wildfire offers, where when traffic passes through Wildfire, we can actually detonate, sandbox the packet. We can see whether to allow, deny. We can create custom signatures. So I think the layer 7 features are still missing. Layer 3 has limitations. It's still applicable, but has limitations. So I think.
And with the, obviously to your point, but the VMCs gives you all these other different full inspection capabilities, the app ID, threat, all those other capabilities. So I actually think that this is a highly complementary, right? It's defense in depth, if you will. So all of this put together gives you the right security posture.
Like you can go back to detecting user ID. You can know who is the user. I think layer 7, layer 3 capabilities and a lot of correlation features. Because you're getting all these individual features from AWS where you can look at VPC flow logs, but how would you correlate it with an event? I think those make it very hard for an incident response process to be successful. So for an incident response process, we want event correlation to be tied down and being able to map every single event to, and being able to trace back to the kill chain.